These are the homework problems for MA104 Section 1-3. We're asked to solve, interpret geometrically, and graph, and then when applicable write our answers using both inequality notation and interval notation. Remember that absolute value represents distance from zero. What this problem is technically saying is that the distance that y minus 5 is away from 0 on a number line is 3 units. So if you think about it, here's our number line, here's 0. The two values that are exactly 3 units away are 3 and negative 3. So our y minus 5, if we go exactly 3 units in the positive direction, our y minus 5 could end up at positive 3. If we go exactly 3 units in the negative direction, our y minus 5 could end up at negative 3. So what we're really saying here is that there's two different possibilities for y minus 5. Y minus 5 could equal negative 3, or y minus 5 could equal positive 3. As soon as we split it up like that, as soon as we set up equations that only refer to what is inside the absolute value, we no longer need these absolute value bars. We've already used them to tell us what the equations need to be to set up. If I solve each of these equations individually, I can add my 5 to both sides. This tells me that y is equal to 2. Over here, if I add my 5 to both sides, y is equal to 8. So my solution set is 2 and 8. Notice how I'm using the braces. If I use brackets or parentheses, that tells me that the solution is everything from 2 to 8 inclusive. I don't want that. I only want the numbers 2 and 8. If I graph this, again, graphing on a number line means I'm just covering the solutions. So anything that's covered is a solution. In this case, my only solutions are the numbers 2 and 8. So I will put points on 2 and 8. This is not an interval, so we can't write it in interval notation. Next, we have the absolute value of y minus 5 is less than 3. Again, if you think about that graphically, I'm talking about distance from 0. So this time I'm saying that y minus 5 has to be less than 3 units away from 0. In other words, it's got to be somewhere in here. These are the numbers that are less than 3 units away from 0. I'm not including the negative 3 and the 3 because we have a strictly less than sign. So y minus 5 has to be somewhere in here. Y minus 5 has to be one of the numbers that I just shaded in my little sketch. To set this up as an inequality, this tells me that negative 3 has to be less than y minus 5, and y minus 5 has to be less than positive 3. So y minus 5 has to be between negative 3 and positive 3. If I solve this compound inequality, I would add the 5 to all 3 sections. Add 5, add 5, add 5. Negative 3 plus 5 is 2, is less than y, which is less than 8. This time I'm talking about solutions that are between the numbers 2 and 8. So anything that's a number between 2 and 8, not including 2 and 8, is a solution to my original absolute value inequality. If I graph this, remember this that we looked at before was just kind of a sketch of a graph to get us started. This will be the graph to our solution. So in this case, I know that my solution includes all the numbers between 2 and 8, but I don't actually want to include 2 and 8, so I'll put open circles around those. This is my solution. As an interval, I use the open parentheses because, again, I don't want to include the 2 and the 8, but the parentheses indicate to me that I'm talking about every number between 2 and 8, every real number between 2 and 8. This time I have the absolute value of y minus 5 is more than 3 or is greater than 3. If I think about this graphically, we know that the numbers positive 3 and negative 3 are a distance of exactly 3 units from 0. But this time I want to go more than that. I want to go further than that. Well, if I go more than 3 units from 0 in the positive direction, that puts me at all these numbers down here. So y minus 5 could be up this way. Or if I go 3 units in the negative direction and then go more than that, in other words, go a distance greater than that, that puts me down here. So y minus 5 could be somewhere down here. The two different sections represent the two different places where I can take my solutions. So if I write these as inequalities, this one would tell me that, hey, as long as y minus 5 is less than negative 3, I have a solution to the inequality. Or if y minus 5 is greater than positive 3, that's also a solution. So I have two different possibilities here. There's two different intervals. If I solve each of these, I can add that 5 to both sides. That gives me y is less than 2. Or if I add the 5 to both sides over here, I get y is greater than 8. So my two possibilities are that y is less than 2 or y is greater than 8. This would be the inequality notation. If I wanted to graph this, I'm unioning these two together. These two sets are being joined together because I can take my solution from either or. There's my 0, there's my 2, there's my 8. If I graph y is less than 2, that would be everything to the left of 2, and I put that open circle on 2. Or if I graph everything greater than 8, the open circle goes on the 8, and I graph everything to the right. So there's my solution on the graph. If I use interval notation, I actually need two separate intervals because I have two completely different places where I can find solutions to this inequality. The first one would be starting at negative infinity and going all the way up to positive 2. The second one would be starting at positive 8 and going to positive infinity. So if I combine that as two intervals, I would have the interval from negative infinity to positive 2, get the open parentheses, and I want to union that with the interval from 8 to infinity. So here's my solution written three different ways: inequality notation, interval notation, graphing notation. The next problem is another equation. I can set this up as two separate equations. U plus 8 could equal 3, or u plus 8 could equal negative 3. If I solve both of those, I could subtract the 8. That gives me u equals negative 5 over here. If I subtract the 8 from both sides in this equation, I get u equals negative 11. So my solution would be negative 5 and negative 11. A better way to write that would be to put the smaller number first. So we could write it as negative 11 and negative 5. Notice how I use the braces, which shows me that these two values are the only two numbers that are solutions, not everything in between. To graph, I only want to cover the solutions, which in this case are negative 5 and negative 11. So I just put the dots on negative 5 and negative 11. This is not an interval, so I cannot write it in interval notation. Saying that the absolute value of y plus 8 is going to be less than or equal to 3 means that it has to be contained between that negative 3 and positive 3. So if I write this as a single interval, or a single inequality rather, I can say negative 3 is less than or equal to u plus 8, which is less than or equal to 3. I want to isolate that variable, so I'm going to subtract an 8 from all three sections. Subtracting the 8 from all three sections gives me that negative 11 is less than or equal to u, my 8's cancel out, which is less than or equal to negative 5. There is my solution as an inequality. As an interval, I can write negative 11 to negative 5. The closed brackets mean that I am including those two numbers. And then to graph, I have my 0, my negative 5, and my negative 11. They get the closed circles because of the less than or equal to. and then I shade everything between. Whenever I'm talking about absolute value being greater than a number, I can actually go off in two separate directions on the number line. So if I go a distance of more than 3 units in the positive direction, that would tell me that the u plus 8 could be greater than or equal to positive 3. Or if I go more than 3 units in the negative direction, u plus 8 could be less than or equal to negative 3. If I solve both of these, I could subtract the 8 from both sides. My 8's cancel, and I'm left with u is greater than or equal to negative 5. Subtract the 8's from both sides over here, and I am left with u is less than or equal to negative 11. So I would put the or in between to show that my solution could come from one inequality or the other one. If I graph both of those inequalities on the same number line, the u is greater than or equal to negative 5 would look like this. The u is less than or equal to negative 11 would look like this. So here is the graphing notation. There's two separate components to this solution, so for interval notation I need two separate intervals. The first one starts at negative infinity and goes up to negative 11. The second one starts at negative 5 and goes to positive infinity. Paying attention to the way that I need the brackets, I would go from negative infinity up to negative 11, and then I will union that with everything from negative 5 to positive infinity. So again, here's the solution in inequality notation, interval notation, and graphing notation. This next equation is a little bit different in that we have the variable both inside the absolute value and outside the absolute value. If you think back to the piecewise definition of absolute value, we said that the absolute value of a number x, actually let's use a different variable than the one in our equation. We'll say the absolute value of some variable r. There's two different possibilities because absolute value is distance and we can go the same distance